So sets, sets are really important. They're really fast. They have O of 1 time to see if an element's in it or out of it. And if you use it right, if you use it cleverly, you can reduce the complexity of our algorithms by a lot. First thing, when it comes to a few drawbacks, like you can't have mutable elements inside it, like lists. There's no notion of like ordering within the set. It's like you're either in it or not in it. You can't index into a set, for example. You can say I want the first element because that doesn't mean anything. We can't have duplicate elements. The way sets work is really complicated. You'll learn more about that in later courses, but we'll talk about hash tables today. Hash tables you can kind of think about as like a list of buckets of elements, and the way you think about like which bucket an element belongs to is something called a hash function, which converts elements of various types like strings, integers, booleans, anything into an integer. So you can determine which bucket an element belongs to and put it in that bucket. And the cool thing is we build these hash tables such that the number of elements in each bucket is bounded by some constant. And so we resize the hash table to have more buckets when we run out of space. And because each bucket has a fixed amount of elements, that takes O of 1 time to see if we know which bucket it's in. And it's very easy to know which bucket we're in using a hash function, which is hopefully fast. Yeah, that's pretty much it.